Hi, everyone. Thank you so much for tuning. As you already know, today is Advanced SQL for data scientists. By the way, thank you so much, Mariano, for accepting my sessions. And I would love to say special thanks to Data Geek Virtual Saturday. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years. I started as a network administrator. Then while working with data team, I love how they do things. I moved to database administration and development. While supporting data science team, I moved from database administration and development into data engineering. I do blog sometimes. This is my blog, bigdatadriven.org. This is my email in case if you guys want to reach out to me. This is my Twitter. This is Cloud Data Driven, a user group that I have. Actually, I am currently launching feature data driven event. If you guys want, you guys are free to go and register for it. It's a free event and we have a lot of great speakers, a lot of great content. The website is the datadrivencommunity.com. Okay. You guys are free to connect with me on LinkedIn. I am from New Jersey, originally from Haiti. So our overview for today is a brief introduction to SQL. I will talk about data preparations in SQL because I have, based on my experience, I have seen how data scientists minimize SQL. And then there's preparing data for use with analytical tools. And I will explain to you the 5 major things to know in RDBMS when it comes to SQL. I will demo some SQL advanced filtering. For some reason, my system giving me issue, but thankfully I have screenshot from previous sessions, so I will use them. And also I will give you some key takeaways. Speaking of SQL, we cannot start the presentation without speaking about RDBMS. So what is RDBMS? RDBMS stands for Relational Data Management System, where your data will be saved in a tabular format. What I mean by where you will be dealing with rows and columns. So RDBMS allows you to create a tons of objects and it manages them for you, like tables, views, synonyms, functions, and procedures, and more. There are 2 types of relational database management system. We have normalization, what normally we consider as production database, or we also call it OLTP, which stands for online transactional processing. Then we have denormalization, which is our data warehouse, and then we normally call it OLAP, which stands for online analytical processing. The things that you need to understand is that all RDBMS are ACID-based compliance. So our agenda for today is SQL. So what is SQL? SQL stands for Query Structure Language. It allows you to control, create, modify, object, and manipulate data. Great. If SQL allows us to control, create, modify, and manipulate objects, so what can we do with SQL? In order for you to master SQL, you need to understand all kind of language, which is SQL support. With SQL, there's a tons of things you can do. The first thing you have to understand is that the primary language on SQL support, we call that language called DDL, which stands for Data Definition Language. Whenever you are dealing with DDL, you have to think of objects like tables, views. When you create your job objects, like you create a table, you drop a table, you truncate a table, you alter it, you comment, or you even rename a database. So anything you are doing when you're using SQL syntax, if it will touch object, you have to think of the DDL, which stands for Data Definition Language. The second language SQL support is data query language. Data query language is the only language that allows you to retrieve or read data from relational database system. The third one is data manipulation language. Data manipulation language allows you to insert data, update a record, delete a record. Do not confund this with data definition language, because DDL is strictly based to object, whereas DML is only at the record level. The fourth one is DCL, which stands for data control language, that allow you to grant and revoke access. So who can access your data, who is not allowed to access your data. DCL is what will allow you to maintain that. The fifth one is one of my favorite one, and is transaction control language that allow you to commit, roll back, save point, and even set operation. Especially, guys, if within your data pipeline, there are some transactions, depending on other transactions. With TCL, you can do a lot of cool stuff. You can go way advanced by controlling the level of your transaction control language. For set operation, it's like, let's say if you don't care about consistency, you can use set operation to say set transaction isolation to read uncommitted data. So there are so many languages in SQL support, as this session is strictly for data scientists, correct? One thing I want you to understand, when you combine DQL with DML, you get what called quad. Quad stands for read. No, the C stands for create, which is insert from data manipulation language. Do not confund this with create from DDL. The second one is read, which comes from query language, select. And the third one is update. Fourth one is delete. So now there are so many, for example, kind of languages when using TSQL, where data science should be focused. As a data science, you should focus only on quad and TCL. By the way, you have to master quad, because if you know data query and manipulation language, there is absolutely no need for you to think of any other alternative when you're dealing with RDBMS data. For TCL, these are the things I would highly suggest you as a data scientist to see if you can have at least a deep understanding of TCL that will allow you to do all kind of cool stuff. Yep. So why SQL? So data is the most crucial part of data science. You can't have data science without data. creating, designing, and communicating with database is essential for any data scientist to grow. So what I mean by, I read on articles where, for example, they want to know what kind of language people use most when it comes to data science. SQL happened to be the first one. And then Python is the second one, but the thing is, Python is not even close to SQL. Let's say it's 5,000 people vote, 4,000 is SQL, 800 is Python, the rest is Scalar and something else. So that's mean even right now, if you are dealing with data leak, there are some technology out there that will allow you to use SQL directly on your files that sit on top of your data lake, like Azure, Synapse, on-demand pool allow you to do that. Anything you are doing, 80% of your data manipulation, even when you're building your model, you can still think of SQL. So now, speaking of SQL, there are some things you need to understand. This is just a recap. There's inner join, left join, right join, full outer join, and then there is a cross join. Inner join will allow you to retrieve data where your criteria happen to be true across all tables. Left doesn't care, as long as the left table have data, it will return it, plus anything happen to be true within your criteria from the right table. Right join does the same thing as well, but full outer join will return all the data. It doesn't matter. Wherever it's true, you get the data. Wherever it's false, you get null. But the thing is, all the data will return. For cross join, it is kind of the special things. Sometimes when doing advanced performance tuning, you know, some developers, they like Cursor to do some thing that cross join can handle much better. So sometimes we may convert that, but cross join is something kind of special. And then if you are doing demo, you want to multiply your data, it is a great tool, you can do that. But all of this is at the objects level. With Transact SQL, you can still kind of do cool stuff against your data set, like apply. It is strictly for Microsoft, which is Transact SQL. Apply have two types of command, which is cross and also out here. And then we also have a pivot that will allow you to do some cool stuff. So here's the thing. Based on my experience, I have seen where data science team spend weight on data engineering team to do some basic data preparations. Because as long as they can use, they can select the data, but they really don't care about when it comes to some functions that will allow them to prep the data and also the procedure. Data preparation have kind of 3 stages. So what is data preparation? First of all, it is the pre-processing steps in which data from one or more sources is cleaned and transformed to improve its quality prior to its use in business analytics. The first stage is the collections. Data collection techniques is information you gather can come from a range of sources like observations, interview, survey, or questionnaire, even case study or database. But things that you have to know is that you have to determine your objective, what exactly you are looking for to achieve. You have to determine who your sample are, like respondent, What I mean by is who are people you're collecting data from to determine your objective, which in turn determine the data collections or strategy. One thing I want you to remember is that the more effort you put into data collection, that greater effort leads to better data quality. So that's mean that said, we have, after you collecting your data, you have to think of cleaning your data. To clean your data, this is where you're gonna spend most of your time as a data scientist, to prepare your data and clean your data. Things that you will need to understand. You have to understand of duplicates, data, outlier, missing data, malicious data, erroneous data, irrelevant data, inconsistent data, even formatting. One thing I want you to remember, one more thing, is that you have to understand, if you only collect your data, you only clean your data, you have to think of garbage in and garbage out. So that's mean it's always best to look at your data and examine it, question your data, make sure, for example, you got the expected result set. Otherwise, you may end up to redo the whole thing. The third stage in data preparation is restructuring the data. After you collect your data, you clean your data, you have to define it, right? So that's when data structure can be defined as the group of data elements which provide an efficient way of storing and organizing data in the computer so that it can be used efficiently. Some example of data structure would be structured tabular row, like rows and columns instead of arrays, linked list, stack, or queue. 99% of the time, you will be dealing with the tabular one. So now, we just spoke about data prep. What kind of SQL function we can use to prep our data? I put this together because based on my experience, it is a lack from data scientist teams, right? When you see for some basic requirement and they have to wait days, even weeks on other team. And these are the things that if they're really willing to get the job done without any other team, they can do that. So the first thing you have to know is the position functions. The second thing is the transformation functions. The third thing is the character set. And then the fourth is sound index. For position functions, as a data science, you have to understand car index, pad index, and length. For transformation, there are tons of them. There's staff, string aggregate, substring, string split, string escape, translate, concat, left, right, lower, upper, length, trim, replicate, reverse, and replace. So that's been all of the, if you can master these two, you guys can say you are very advanced. Because when it comes to data preparations, positions and transformations functions are good enough for you guys to do any kind of cool stuff without even thinking of Python. For character set, you need to understand, because sometimes the data may be ugly enough where you will have to come up with a way to ignore empty line, where replicate, where replace may not help, even trim may not help. You have to think of a way to ignore those. And also, if you want to convert a car to ASCII code to car, Unicode. So these are the things. For sound index, you guys probably familiar with that, especially when it comes to Python, you have to think of difference and index. But I guarantee you guys, the first two functions to prep the data, it's good enough for you. Because with the position and transformation, you will be able to do cool stuff. So let's go to a demo. My system shut down on me, but I have a screenshot from my previous sessions. I hope you guys enjoy it. So for data preparation functions, so I'm gonna start with positions just to show you some cool stuff. So the same thing can apply against a giant data file, right? Let's say if you have this string, say, okay, this is a great event. In our case, we need to extract grade. We need to know, in order for us to extract grade, we will need to know, for example, where grade is located. So that's the beauty of car index. So you have to put the expression to find, expression to search, and then there is a start locations. So if you're looking at here, all I'm doing is car index, expression to find is grade, and expression to search, this is a great event. And then I can see it's 11. So now if I want to extract this, because this is kind of an easy task, I can see the length is 5. I can use substring, which is a position function plus transformation functions. I can combine both type of functions to get what I need. If you're looking at for substrings, so the string is required, the start is required, the length is required. So what I mean by, if I say select substring, I put the string to extract from, and I have my car index that will allow me to dynamically locate the positions of grade. And I put that same string again back, and I said, okay, as this is 5 characters, but we can dynamically handle this. I don't want my screenshot to be too complex, so that's why I quickly put that so it's easy to read. So when we execute it, true enough, we have grade. So that's when with Python, it might be a bit complex to do this, but with SQL, it's just like a single line. So it's the same thing. For example, let's go a little bit complex. If we have this, they want us to find anything that contain big and end with driven.org, correct? If you're looking at this is a bigdata.org, so that's when we won't get that result. The goal is to start anything with big and end with big data driven. As you can see, there's bigdata-driven.org, there's bigdata-driven.org. So that's when this will be validated. Car index cannot help you there because car index cannot use expressions. One thing I want you to know, however, part index will allow you to do some cool stuff. So what I mean by is that I can match any string or any length, including 0 length. I can match one single character. I can match any character in the bracket. I can match any character not in the bracket. And then the string is required. So for this requirement, I'm trying to generate the data. All I'm doing is substrings, which is part of transformation functions. I'm using part index, which is part of the position functions. And I am trying to define that pattern. And when I execute it, sure enough, I got 2 records. I did not get a big data because it didn't end with driven.org. So this is how simple we can do this using SQL. So let's say, for example, if you have this format, they want you to have it in this format. Before we would use staff plus for XML, but now since SQL Server 2017, they give us string aggregate. This is the instructions to use it. So if I want to combine this, what I'm doing here is that I'm using string aggregate functions. I pass on the name, and I said I need the delimiter to be a comma. As you can see, we quickly change this. Kind of easy stuff when you are using SQL. So let's say if you have your data like that, you know, sometimes business is kind of funny. They may say, okay, I need whoever have more than one font, I need each one to be in a different line. Split string is the one that will allow you to do that. If we're looking at, you just pass the string and then you pass the separator. When we execute this, this is the data, the same format of this data. And then when we cross-apply this with string split, we were able to split that data, which is, this is very simple stuff. It may look like I'm demoing it simple, but it is not really. You can do cool stuff with that. Yep. So beside data preparations, things that I want you to understand is the SQL aggregate and analytical tools. You have to be able to understand when you're dealing with aggregate, what kind of functions available, and when you're dealing with analytical, what kind of functions available, and when you're dealing with windowing functions, what kind of functions available. As you can see, for aggregate, we have min, max, standard deviation, we have sum, we have a tons of them, checksum, average, approx count, distinct. For analytical, we have first value, which we will demo, lag, we have last value, lead, percent rank. And then when it comes to windowing functions, one thing I want you to remind you is that the default is in temp DB, and you may even get wrong data when you use range. Range is the default. There's a penalty, which is performance, right? It would be best if you can explicitly mention rows, which is in memory. Not only you get better output, but when it comes to performance, you will increase your performance as well. So, and it supports some keyword like preceding, following, unbound, and current. Not only that, for ranking, we have row number, rank, dense rank, and tile. So let's do some let's go to some demo. If business want us to provide the total sales due, total average sales order, total number of sales, okay, and then and total sales rank, order for each year, including all fees. So what I like to do, I like to break that down. They just want us to get all sales order for every year. As you can see here, they want us to calculate sums of total due per year. We have this. They want us to do the total average of sales order per year by year. So we have this, and they want us to do the total number of sales order by year. We have this, and they want to know how well products are selling relatively to other years. So we use rank to do that, as you can see. Okay, but remember, we have to use group by, because we are grouping by year. So when we execute this, marketing team can clearly see, okay, 2013 is the date where we made a lot of sales. They can use that data to review the product they sold during 2013, and also they can do kind of promotion, all kind of stuff they can do just to see if they can not only replicate 2013 and also beat that number, bring more sales. So let's say if they want you to run running total, okay, they want you to provide the daily running total due on sales order and include customer ID, sales order ID, order date for the period of June 2014 onward. And we have to order by sales order ID and date. So if you're looking at here, the main goal is what we want, correct? So I'm doing a sum and over and order by sales ID and rows unbounded preceding, so as running total ascending. Because they want it to be June 2014, June 1st, 2014 onward, so I put that criteria, correct? When I execute it for the demo purpose, I just select top 10. As you can see, this is the first total sales. So we have the running total is exactly what we think, because there were no previous sales. When you add this one with this one, we got this one. You add 41,000 with 28, you got this guy. So that's when the more you add it, you add 70 with $8 something, you have 78. So this is how easy you can do running total using SQL. So now let's go a little bit advanced. Let's say, for example, if the marketing team has asked you to return the first 3 orders plus the close price, total order due, total order for every customer that purchased more than 50 times from us. The question is, they have to purchase 50 times from us. If we're looking at, we need to find all order details per customer, because we need to get the first 3 orders. We cannot use workloads when we're using windowing functions. So I'm declaring a CTE and call it first 3 orders. And I use the row number. This is where I'm generating the row number. And I just want it to be anything that is less or equal to 3. And then also, because they want me to only provide information for customers that's purchased more than 50 times from us. So this is where I do the count. I partition by customer ID and order by customer ID and call it total orders. As you can see, and now I need that total orders to be greater than 15 and order by this. If I execute this, you will see, let's say this customer ID, right? We were able to bring only the first 3 times they purchase from us, the first 3 times. However, if you're looking at the total order is 17 times, which is greater than 15 times. And if you go to the third one, that customer purchased 28 times from us, but we were able to only bring the first 3 times they purchased from us. Okay, so let's say a business user has asked you to return all order from the sales order header table for any customer who had over 10,000 in purchase for the first 3 transactions. Let's say if there's a promotions, that's what they want to do. Okay, so how can we do this? First, we need to find the first 3 order by customer. So this is what we are getting here. First of all, that's we need to get sales by customer. This is what we are getting. And then we need to get the first 3 orders. If you're looking at sales by customer ID, we are filtering within the second CTA, right? And then we have to aggregate the first three order. This is what we're doing here. And then we return all order for those customers. So that's when we have to join this back to the main table to get all other informations, right? After we retrieve the first three one. So now we have to return all customer with over 10,000. So that's when we don't care about anything that is less than 10,000. So we need for everyone that have 10,000 when we execute this. If we, for example, plus all of these three, if we plus it, you will see, for example, it's gonna be $10,593 plus some change. And not only we were able to do that, we also were able to bring all kind of other details, you know, and then same thing apply for this one as well. So this is kind of complex if we have to use Python, whereas with SQL, it is just a few line of codes. So now, if business wants you to find the first and last close price for each day of every month of the year, including single details, so how can we do that? For the demo purpose, I'm using the top 10. So they want me to have the first and last close price. So the first value, I use an aggregate function for windowing function for that. Not windowing, I'm using analytical functions for that. So the first value is that I use over and partition by month, because that's what they want for every month of the year, right? And that gives me the first close price. The last value will give me the last close price, and I'm using the same when I execute this. If you're looking at the first close price was 201 and 4 cents. Sure enough, it is 201 and 4 cents. The last close price was $171 plus some change, and then that's how you can calculate it. And then if you go here, it's gonna be the same. If you keep analyzing it, it's gonna be the same. This is first and last value will allow you to calculate first and last close price. So now this is a little bit advanced, way advanced, guys. Let's say if you have this format and then business wants you to calculate the total due for each month and get the total for each year by region, and then this is the data. This is just a snapshot of the data. So how would you do this? So we want this value to be like this value, as you can see. So they just want the month instead of numbers. They want the month name. And for each country, they need to know for each month how much is it, and the grand total for each month. So how would you do that? This is a query, for example, that will allow us to do that. I want to give that credit to that person. I modified it a bit, but that wasn't out. I got that manuscript from someone at the articles. I don't remember, but I want to give that credit to that person. Yep, so what I'm doing here is that I'm defining the surrogate key, right? And I am extracting the date, as you can see. I'm putting all this calculation into a temp table, and I'm using sum for each country using case statement from the table that I dumped the data, the temp table, sorry. And then I am using union all to get the total, because they want the total. When I execute this, true enough, I get the total and I get the month total for each one of them. Okay, so things that I want you to understand. I'm completely done with the demo. The 5 major things you need to know in RDBMS is quad. You have to know quad. You have to master it. You have to understand how it works. You understand? You have to play with it and remember the positions and transformation functions. You have to master this as a data scientist. And then you have to understand you're dealing with ACID because RDBMS, ACID-based compliance, you need to understand this. So if you understand it well, this knowledge is the one that will allow you to do cool stuff when you're using TCL. And then things that I want you to understand after you're done with your data pipeline, it would be great sometimes to understand how your query will execute on production. Yeah, have a basic understanding on query optimizer may help a bit. And then I know it's gonna be hard for you to request to create index and everything, but it would be great as a data scientist to know when to use index. And one more bonus is that anytime when you create your data pipeline, I would highly suggest you to think of exceptions. If something wrong occur, how would you log that exceptions? That will facilitate troubleshooting. So the key takeaway is that you need to have a deep understanding of ACID. You need to master quad, which is a combination of data query language and data manipulation language. You need to know that, and then you need to know when to use TCL command, especially if within your data pipeline there are transactions that depend on other transactions. Your feedback is important to us. Don't forget to rate and review this session. I would love to have that. Thank you so much for attending. And if you guys have any questions, feel free to ask.